So in this example, we're going to be talking about how to evaluate factorials without a calculator. Now, before we can do these problems, you have to understand what a factorial is, and it's really simple. So for example, if you look at my numerator here, I have 9 and then the explanation point. That means a factorial. So this explanation point right here is your factorial, and all that's telling you to do is you start at 9 and you multiply down until you get to 1. So for example, I would do 9 times 8 times 7 times 6 times 5 and so on until I get to 1. That is what a factorial is telling you to do. It's pretty straightforward. But you can see that this number is going to be huge, right? Same thing on my denominator. This is going to be a pretty big number. So how do you do this without a calculator? Well, let's go ahead and get rid of this stuff here and we'll talk about it. So getting rid of this here, look at your numerator. How can we expand that out? Well, like I said at the beginning, we could do 9 times 8 times 7, right, times 6 and so on. So why don't we go ahead and do that? I'm going to write it as 9 times 8 times 7 times 6. Now I'm going to stop right here because look, I have a 6 on my denominator, but it's a 6 factorial. Okay, not a big deal. I could actually write this as 6 factorial, and essentially that's telling me to now do 6 times 5 times 4 times 3 times 2 times 1. But since I also have it on my denominator, they'll cancel out. So for example, I have a 6 factorial on my denominator. These will cancel out, and now all you have to do is 9 times 8 and then times 7. So we know that 9 times 8 is going to be 72, and then I just have to do 72 times 7, and I'll have my answer. So I get 14 here, carry over the 1, I get 50, so I end up with 504. So your answer here is going to be 504 or 504. Okay? Let's go ahead and try another example. So here's our next example. Again, you have more factorials, and if you were to expand this out, these would be huge numbers. So let's work smarter here, not harder. I have a 10 factorial on my numerator. I'm going to go ahead and expand that out all the way until I get to 8 because I have an 8 factorial here, and those will cancel. So for example, I'm going to write it as 10 times 9 times 8, and now I'm going to write the 8 as a factorial. Okay, all over 2 factorial times 8 factorial. Now the 8 factorials, they're going to go ahead and cancel out. I know that 10 times 9 is 90, so I have 90 all over 2 factorial. Well, 2 factorial, that's 2 times 1, which is 2. So I end up with 90 divided by 2. So 90 divided by 2, which we know is going to be 45. So 45 is my answer here. Okay, let's go ahead and try another example. So here's my next example. This one's a little more tricky. So what do I need to do here? Well, I have a 12 factorial on my numerator, and I have this 9 factorial here. So what I'm going to do is I'm going to get rid of that 9 factorial by expanding out this 12 factorial until I get to 9. So for example, let's go ahead and write it out. 12 times 11 times 10, and now I'm here at 9. I'm going to write it as 9 factorial, okay? All over 9 factorial, and then times 4 factorial, okay? So the 9 factorials will cancel out, so this will cancel and this will cancel. And now I still have fairly large numbers here. Is there anything else I could do here? Now this is not very obvious, but this 4 factorial here, okay? Think about how you could expand that out to possibly get something else to cancel out. Remember, 4 factorial is going to be 4 times 3 times 2 times 1. And so you can see here, I have this 4 times 3, which I know is really 12. And I also have a 12 here. So if I rewrite this as 12 times 2 times 1, the 12s will cancel. So for example, on my numerator, I have 12 times 11 times 10 all over, I'm going to write this portion here that we just figured out, 12 times 2 times 1. Now the 12s will cancel, so these cancel. I know that 11 times 10 is going to give me 110, so 110 all over 2. When I divide that, I get 55. Okay, so I get 55 for an answer here. Okay? All right, let's try one more example. Okay, so here's our last example, and just like the other ones, we're going to see if we can cancel anything out. I see that I have a 7 factorial right here. I have an 8 factorial here on my numerator. Well, I can expand out that 8 factorial until I get to 7, and then I can write it as a 7 factorial. So again, for example, I'm going to write it as 8 times 7 factorial all over 7 factorial times 3 factorial, okay? We know that the 7 factorials, they're going to cancel out, okay? And now I have 3 factorial on my denominator, which is really 3, times 2 times 1, which we know is going to be 6 here. So I have 8 over 6, okay? And then we can reduce that down. We know that 2 will go into 8 4 times, and 2 will go into 6 3 times. So there we go. There's our final answer. And again, you could write that as a decimal. That's going to be 1.3 repeating, okay? But I'm going to leave it as a fraction, all right? That's totally fine. So that is how you evaluate factorials. It's pretty straightforward. Always look for the path of least resistance, especially if you're not using a calculator, all right? If they're asking you to evaluate these factorials without a calculator, you know that there's going to be ways in which you could cancel out some of these factorials, all right, to make it much easier. That way you can use mental math. All right, so that's it. I hope that you learned something from the video. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.